Hello, my name is Nicole Cruz, and I will be discussing the possible exploration for planets for human colonization and the search for life beyond Earth through the Transiting Exoplanet Survey Satellite, or for short, TESS. TESS is a NASA-sponsored astrophysics Explorer-class mission that is performing an all-sky survey to search for planets transiting nearby stars. The main goal for the TESS is to discover planets outside our solar system that are smaller than Neptune. They do this by scanning the sky through bright stars that enable it to make follow-up spectroscopic observations that provide vital information like atmospheric compositions and planet masses. TESS was launched on April 18, 2018 and began regular science operations on July 25, 2018. It was placed in a highly elliptical 13.7-day orbit around the Earth in hopes of completing a 2-year prime mission, monitoring about 200,000 dwarf stars with special cameras that will later be discussed in depth, that detect periodic drops of brightness caused by planetary transits. Images will be recorded every 2 minutes and will be created through FFIs, or full-frame images, at a cadence of 30 minutes. According to Sci-Fi Wired, astronomers announced the first confirmed planet orbiting another star, a pulsar, in 1992. 3 years later, one was found orbiting a sun-like star, then more followed. Not long after that, transiting exoplanets were found. Because we see some exoplanets with their orbits edge on from Earth, they pass directly in front of their host stars. When this happens, an orbiting exoplanet blocks a little bit of the starlight, and we see the star's brightness dip. It's usually a small amount, but with big planets and small stars, the transit can produce a dip of 1% or more, easily detectable with modern equipment. NASA had launched the Kepler mission in 2009 to look for more outer planets and found one spot sitting in the constellation of Cygnus, starting at a brightness of about 150,000 stars. It has found more than 2,300 confirmed exoplanets and similar suspected planets. It had suffered some mechanical problems that made pointing an issue, but engineers were able to salvage the mission. Now it sweeps around the sky with less ability, but it's still functional. This K2 mission has found over 300 more exoplanets. Now it sweeps around the sky with less ability, but it's still functional. This K2 mission has found over 300 more exoplanets. Kepler was designed to look deep into the galaxy, sensitive to faint stars to maximize the number of planets it could find. TESS will answer a different but no less important question: where are the nearest rocky planets? To do this, it will scan 85% of the sky, which is 200 times the area Kepler had done, to look at the 200,000 or so of the brightest stars, measuring their brightness and seeking out transits. These stars are closer to Earth, less than about 300 light years or so, to find the nearest galaxy. It will find a lot of planets in total, but estimates are that it should find roughly 50, similar than about 4 times Earth's diameter. TESS contains many important structures to maintain the satellite in proper shape so that it can communicate effectively to Earth. The sunshade provides protection for the cameras from the sun's heat, and the thermal blankets are wrapped on the exterior of the spacecraft to keep out the heat as well. Thermostats and heaters control the temperature from the inside of the spacecraft. A star tracker is visible from the outside of TESS and is a camera that takes pictures of the stars from wherever it points at. Its solar arrays use the sun's solar energy to produce 390 watts of electricity. TESS also has 4 spinning reaction wheels to orientate the antennas and to maintain precision during data collection. The master computer controls and stores all coded instructions to the spacecraft. The propulsion tank holds the fuel, called hydrazine, that it can use without and throughout the mission to stay in orbit. 5 small thrusters can propel the spacecraft, while its structure or skeleton is strong enough to survive the stresses of the launch. The antenna transmits the data that is sent to Earth every 2 weeks as well. TESS was led by MIT and focuses on capturing detailed images of outer space and its outermost planets. TESS has 4 identical red-sensitive wide-field, highly optimized cameras that can monitor a 24-degree by 90-degree strip of sky. Its goal is to spot hundreds of super-Earths, which are extrasolar planets similar to Earth, but with a greater mass, but no bigger than Neptune. The cameras have custom lenses with 24 by 24 degree field of view. Its aperture size is 10 centimeters in diameter, and its high cadence is crucial for the detection of planets. The Falcon 9 rocket by Elon Musk was created to transport the satellite into orbit. Falcon 9 has a large structure with its payload composite at the top, carries a pressurized capsule as well as an unpressurized trunk that will one day carry humans. Right below the Falcon's 9 cargo is the second stage of the rocket, mainly powered by one Merlin's vacuum engine and can usually ignite a couple seconds after stage separation. After the second stage, the inner stage is set. This composite holds and releases the first and second stages using an all-pneumatic stage separation system for low shock. Unlike most pyrotechnic systems cast off by most launched vehicles, the all-pneumatic stage separation system is built for low shock and reliability, a keyword to most of Elon Musk's rockets. There truly has been several attempts at exploring the celestial unknown, and TESS has a list of possible discoveries, which include transiting planet hosts, known exoplanet hosts, pulsating stars, rotationally variable stars, flaring stars, accreting stars and interacting binaries, binary stars, open clusters, stellar associations, galaxies and supernovae, active galactic nuclei, microlenses, solar system planets, asteroids, comets, and many more. With negotiations going from NASA and SpaceX, humans will soon travel to space in hopes of finding a new home and advancing humanity into someplace else. Neil deGrasse Tyson once said that we do not simply live in this universe, the universe lives within us. The world is full of possibilities because, after all, we are just a speck of dust floating in a never ending ocean of stars and planets just waiting to be discovered. Now, the real question is, are you ready?